Good morning, dear all. So, we will see question number 6. Question number 6, the set A is given here 1, comma 2, comma 3, and the relation is defined here 1, comma 2 and 2, comma 1. Only two elements in the relation. We will prove that this relation is symmetric but neither reflexive nor transitive. We have to prove. So, first one is reflexivity. Reflexivity should be true means A comma A belongs to R for all elements of A belongs to the capital A, belongs to the set. So clearly we can say 1 comma 1 does not belongs to R. So R is not reflexive. R is not reflexive. Next, check the symmetry. Symmetry means what? A comma B belongs to R means B comma A also belongs to R. Clearly I can say 1 comma 2 belongs to R. Here 1 comma 2 belongs to R and 2 comma 1 also belongs to R, except these two elements, no elements are here. So this 1 comma 2 is symmetric. Similarly, 2 comma 1 belongs to R, 1 comma 2 also belongs to R. This element is symmetric. So the whole relation is symmetric. So R is symmetric. Next, we have to check the transitivity. We have to check the transitivity. So what is transitivity? A comma B belongs to R, B comma C belongs to R. This implies A comma C also belongs to R means we can say that transitive. If does not imply means we can say that it is not transitive. So this case is what? 1 comma 2 belongs to R, 2 comma 1 belongs to R, but 1 comma 1 does not belongs to R. So clearly I can say here 1 comma 2 belongs to R and 2 comma 1 belongs to R, but 1 comma 1 does not belongs to R. So I can say that R is not transitive. Clear? So this relation is not reflexive, not transitive, but symmetric. Clear? Next question. Question number 7. So what is given? Question number 7 means set A is given that set A equal to set of all books in a library. Very elementary question. So what is the relation defined here means x comma y such that x and y have same number of pages. X and y have same number of pages. So I need to prove that it is an equivalence relation. Clear? First time we are seeing the word equivalence relation after defining that. So okay, now we will see. First we will check that reflexivity. What is reflexivity? X comma x belongs to R means we can say that it is reflexive for all x belongs to the set A. So here clearly we can say that x comma x belongs to R because x and x have equal number of pages, that is same number of pages or equal number of pages. Yeah, x and x means two same books having equal number of pages, so it is clearly reflexive. So R is reflexive. Next, symmetry. What about symmetry? Symmetry means if A comma B belongs to R, then I need to show that B comma A also belongs to R. That is called symmetry. Clear? So see the symmetry. If I am writing here, if x comma y belongs to R, that is x and y have same number of pages. So I can in reversely and write what is that? Y and x have same number of pages. So I can clearly say y comma x belongs to R. So R is symmetric. Clear? So now reflexivity over, symmetry over. Next we have to show that it is transitive. So transitivity. What is the definition of transitivity? If x comma y belongs to R, y comma z belongs to R, mean that should imply x comma z also should belongs to element, so that belongs to relation. So if x comma y belongs to R and I am taking y comma z also belongs to R, what is the meaning of this? X and y have equal number of pages. Similarly, y comma z belongs to R means y and z have equal number of pages. So x and y have equal number of pages, y and z have equal number of pages. So that is x, y, z. For example, x having 60 page, y also have 60 page. Second, I am relating y and z. Y having 60 page means z also having 60 page. So x and y are related, y and z are related, means clearly we can say that x, z also related. So x and z are also having equal number of pages. This shows that x comma z belongs to R. So I can say that R is transitive. So if R is symmetric, reflexive, transitive, three cases coming, mean three relations true, means I can say that R is an equivalence relation. R is an equivalence relation. So a relation is an equivalence relation, means that is reflexive, symmetric and transitive. Clear? Now come to question number 8. Question number 8. So question number 8, in that set A is given that set A equal to 1, 2, 3, 4, 5, and relation R is defined here. What is the relation defined here? Means A, B, ordered pair A, B. In that ordered pair, modulus of A minus B is even. Modulus of A minus B is even. That is, we have to take two numbers. We are taking difference. That difference is an even number. Like that, the relations are we are defining. We have to show that it is an equivalence relation. Clear? So that it's an equivalence relation. So first equivalence relation means what I said, we have to prove it is reflexive, symmetric and transitive. So we will prove one by one. First, reflexivity. What is reflexivity? A comma A should be in the set. Clearly we know that 0 is an even number. 0 is an even number. So 0 can be written as A minus A. So A minus A is also an even number. So I can write that A minus A is an even number, means I can say A comma A belongs to R. So R is reflexive. So R is reflexive. Next, symmetry case. What is symmetry definition? If A comma B belongs to R, then B comma A also belongs to R. So I am taking if A comma B belongs to the relation. That is, what is the meaning of that A comma B? A comma B, what is the meaning here? So A comma B means modulus of A minus B is an even number. If modulus of A minus B is an even number, means here what I can do, I can take minus outside inside the bracket, inside the modulus is also an even number. So modulus of negative number is positive. So modulus of B minus A, this is also an even number. So I can write B comma A also belongs to R. If B comma A belongs to, I have taken A comma B belongs to R. I have received here B comma A belongs to R. So clearly I can say R is symmetric. Clear? So reflexivity over, symmetry over. Next we will check the transitivity. transitivity. So we have to take that if it is transitive we need to show means we have to take A comma B belongs to R and B comma C also belongs to R. So what is it showing? If A comma B belongs to R means modulus of A minus B is even and modulus of B minus C is even. So these two are even means I need to show that modulus of A minus C also even. See that here I am writing modulus of A minus C equal to inside the modulus I am adding minus B to compensate that I am adding plus B minus C. This can be written as modulus of A minus B plus modulus of B minus C. We know that sum of two even numbers. So we will write that we know that sum of two even numbers is even. So A minus B is even, B minus C is even, sum of two numbers is also an even. So I can say that modulus of A minus C is even. This implies modulus of A minus C is even. So A comma C belongs to the relation. I have taken A minus B belongs to relation, B comma C belongs to relation. I have arrived A comma C belongs to relation. Therefore R is transitive. Therefore R is transitive. So finally I can say R is an equivalence relation. R is an equivalence relation. So one more additional questions given in this same. I think two questions given. Yes. So we have to show that all the elements of this set 1, 3, 5 are related to each other. Why means we can say that all the elements of set 1, 3, 5 are related to each other because difference of any two odd number is even. So we have defined the relation here, difference between the two numbers is even. So we can say that any two elements we are taking and relating mean that will be even. 1 minus 3 is even, 1 minus 5 is even, 3 minus 5 is even. So all the elements are related to each other. But another one case, what is the given that one more case is given 2, 4. 2, 4 also we can say that all the elements of 2, 4 related to each other because difference of any two even numbers. Here we can in the place of odd we have to replace even. Difference of any two even number is also even. So these elements are also related to each other. This set of elements are also related to each other. But one more case is given. What is that? We have to show that 1, 3, 5 is not related with 2, 4 because it is not related. Clearly you can say because difference of any two numbers, that is difference of odd number and even number is odd. That is difference of one odd number and one even number is odd. Difference of odd number and even number is odd. So I can say that this set contain only odd numbers, this set contain only even numbers. If you are finding Cartesian product, the ordered pair will come always one odd and one even. For example, if you are trying to find the Cartesian product means, for example, this is 1, this is 3, this is 5 of the elements of the set A. 2 and 4 are the elements of set B. Finding the Cartesian product 1, 2, 1, 4. One odd, one even. One odd, one even. Similarly, 3, 2, 3, 4. Odd, even, odd, even. 5, 2, 5, 4 also odd, even, odd, even. So all the ordered pairs will contain one odd number, one even number. So clearly we can say that these two sets are not related to each other. That is, no element of this set is related to any element of this set. Clear? Thank you. Next class we will see question number 9 and 11. Thank you all. Subscribe and share.